Hopefully you can hear me okay. Welcome in. Let me do my sound test real quick. Testing, 1, 2, 3. Testing, 1, 2, 3. Do my sound test real quick. Testing, 1, 2, 3. Yep, that's good. Can't really hear the music, but that's alright. Alright, so it's been a few days. Had a couple of appointments, so I couldn't stream, but yeah, tonight what I want to look at, I think, is the dungeon generator. So we have this because I want to start getting quests ready to go. We have this procedural dungeon stuff up here, but I don't really like the way it's done. If I just generate that, yeah, it's like a like basically just always a bunch of tunnels. Maybe that would be good for some types of dungeons, but I want to generate more like normal dungeons, I guess, at least to start. So what I have found is an algorithm which I want to try and implement today, or at least some of it today, called binary something something BSP tree. I can't remember what it's actually called, but essentially, if I understand it right, we just basically build a tree structure by taking an area and continually splitting it randomly in two until we get to like a certain depth. Yep, and then we basically just put rooms inside those areas and then connect them. So I mean, it seems pretty simple, but yeah, so I want to start trying to work on this, and we'll see how we go. So to do that, we have already a dungeon generator, I believe, which I'm probably just gonna modify, honestly. Yeah, so we've got all this Walker stuff. I don't know. I am probably just going to start over with all this. Maybe we should keep it. Let's see. What do we actually use this for? Nothing. Okay, cool. Yeah, so I'm just gonna, I've got it in source control now, so I can always come back and get this code back again. But I'm pretty much just gonna get rid of a lot of this. We'll keep a seed. Max size. Sure. Okay. Alright, like, we'll just get rid of all this. And let's see. So now we don't need any of these. And yep, now we need to do the actual dungeony stuff. in this function. Okay, so we're ready to go for that. Let me just get that compiled in. So I have just some basic like block meshes I'm going to use for now. I might change out how I do this later, but for now this will probably work fine. So they're literally just cubes, and we'll build the dungeon using these, I think, Minecraft style, and we'll see how we go from there. Essentially voxel dungeons. So hey, welcome in. Nice to see you. How's it going? Alright, so did that compile? It's still compiling. Okay, yeah, that's right. The first one takes a while. That's alright. While that's compiling, we can kind of get started on this. Is this Minecraft? No. It's not Minecraft, but yeah, I guess I'm going to be doing some voxel. Like, it's kind of what I'm thinking for some of the dungeons and buildings in the game, is just to build stuff out of voxels, because it's kind of easy to programmatically do that. And I might switch to actual meshes later. But yeah. No, this is the same sort of fantasy RPG project we've been working on for a while. One day I should make a Minecraft clone on stream, though, I think. I've done a few of those. I think that would be fun. Okay. Right. Yep. So that compiled. Okay, so essentially what we want to do then is I think start with a layout. So these are villages, yes. Well, they're just NPCs really. I can't remember if you've seen this project before, but if I go to the village, you can see better. These are procedural villages that get generated. And yeah, the NPCs, obviously. I don't have any walking around town yet. That's something we've still got to do. But yeah, the villages use an LLM, large language model, for their dialogue. So it's all like procedural AI dialogue, which appears to be running very slowly for some reason. What the hell? Did I break something? I might have broken that. Or maybe it's not running with Kudo or something. Oh no, here we go. Yeah, so they are basically villages, yeah. They get generated some like NPC data and whatever, and then you can just talk to them. There we go. Right, doesn't look like he actually wants to say hello. Or she says she doesn't want to say hello. Yeah, anyway. That isn't part of what we're going to work on today, probably. But I do need to do some more work on these guys soon. But yeah, today is dungeon generation time. So I think essentially what I'm going to do is a 2D array. Of bytes. Maybe. And this can definitely be protected. And we don't probably need to uProperty it, but I will. Okay, so when we generate, we'll do, let's see, layouts data.set num to, we had, yeah, max size. So because it's 2D, we need to square that number. So that will create us basically like a big 2D grid of data. And now we need to fill that data. I'm just thinking this through in my head as we do it, but okay, let's see. So what we'll probably want, I guess, is a struct. Dungeon BSP. How's the audio, by the way? Is everything sounding okay? Now, I'm not sure if structs can really have pointers to the same type, so I don't know if I can do something like that or not. No. I seem to not be able to do that. Let me quickly figure out how I can do this. Right, index of the array, thought of the pointer. All right, that's fine, we can do that. Now, so we've got that, and then we'll do another struct called Dungeon BSP. And we're gonna want an array of these. How's it going, Shaik? Welcome in. Nice to see you. Create node. Let's see. So when we generate, we want to make a BSP. This kind of comes last. This is the actual layout generation. For now, we need to build up the BSP tree, which is essentially this structure you see on the right of these images. So let's see. Dungeon BSP. Okay, so the Dungeon BSP is going to need a root node, which I guess can be node 0, to be honest. Maybe do it like this, and I'll return the index. And let's just write this all inline, I suppose. Yeah, so we pretty much just want to say nodes.add node and then return the nodes dot last or length, size, whatever it is, num -1. I've been jumping around a lot of different languages lately, so pass that in by const reference, store it in here, return the ID to it. Okay, that will work. So now in the generate function, what we want to do probably is create a root node. So dungeon BSP node, root node. And then add it to the BSP tree. Let me bust out paint. So far we have we're trying to build a tree structure, and so far we have basically the entire area as a node. So this is the node. The whole where the dungeon is going to exist is now this root node. So now what we need to do is split this at like a random kind of location. So root node split horizontal, maybe. Okay. So when we split horizontally, maybe I should be doing this in the header in the CPP actually. We need to get, oh shit, okay. Split horizontal. We can't reference this within itself, can we? We don't need that because we have its own thing. Okay, so we need float split alpha, maybe, and bool is horizontal split. BSP node split horizontal. I want to put this code in here, but the problem is I need to access this array, which is in a different struct. And I'm pretty sure maybe it will be okay with me doing this. Nope. Okay, maybe it will be okay with that. So now we split like this. And when we do a horizontal split, we just want to do BSP dot add node. Can't really do const reference, can I? Take that out. So we want to add 2 subnodes. So okay, so we add those in. That gives us the number. So we should be able to say like child A equals this, child b equals this. And because we're doing it horizontally, we want to say is horizontal split true? And we want to generate a random alpha. Split alpha. Between 0 and 1. So that is going to represent like how far across this is, this being 0 and this being 1. So what we're going to do is we're going to take the root node, we're going to split it horizontally, which will create 2 subnodes, and it'll put the sort of split somewhere randomly here, and then it's going to create a node A and node B, like that. So now we have the first layer done, and then now what we need to do is do this again recursively, but change the split direction each time. So if this is A and B, then we would split A somewhere like, probably not in the middle, but maybe like here, and B like here, and now we would get a new A and B, if that makes sense. And then we just kind of keep doing that. Yep. So that means we're going to need a split vertical function as well. Come on. There we go. Which does the same thing, except this is no longer a horizontal split, basically. Okay, so now we have the functions we need. We have this. So now what we're going to need is to recursively do this in the generate function. So we'll split this. Okay, let's see. Let's think this through. Okay, so that is the node. The split will create the children. Wait, let me just make sure I'm doing this right. So oh, it reckons a random direction. Okay. Yeah, okay. So we don't need to really alternate then, it's just random. So we actually don't need to know, oh, we do need to know this then, yeah. But we can just pick to run one of these functions kind of randomly. In fact, then we could just convert it to one split function and just make this rand bool. Like that, and take this out. So we only need one split function now. I thought we had to alternate, but it looks like we don't. Okay, so there we go. We have a split function. Now I'm trying to think about how to do this recursively. Recursion is always confusing, but to make sure we get down to the same depth. So in fact, same depth, that is a good point. What we want to probably have is have the actual node know what depth it's at. So yes, so then depth we'll just do this. So we go one further into the depth every time we split. And then we just need to initialize the root node. That's like the first layer, layer 0. Well, I guess we could 0 into it, dex it, and then we don't need this line. So layer 0 is the first depth. So let me just kind of YOLO this, and I'll see if I get it right. I probably won't, but we'll have something to refactor. So when we call split, what we'll do is we'll say split, here we go, I have an idea. Okay, so let's do max depth. And this should generate it all in one function call, I think. So if depth is greater than or equal to max depth, then we can just return. Otherwise we split, and then on node A we split that. And then we split node B. And that should just keep going down down the tree. And then we say max depth of like 4 or something like that. And then that should be it. Okay, so let's see if we generate the proper tree. So that should essentially just like keep doing this. So this is layer 0, then 1, then 2, and then 3. It's getting really confusing. And then 4 would be one more split after that. Something like that or whatever. What keyboard do you use? Welcome in, Nightsick. It is it's over there, the box, the Leobog High 75 keyboard. It's one of those, I don't know if you've come across the like kind of creamy orthocky keyboards on TikTok. That's where I found it anyway. Hey Gandev, welcome in. Nice to see ya. Alright, so yeah, let's see if this works. So it should basically recursively do it just off this one split function, hopefully. And that'll give us the BSP to work from to get to the next step, which is essentially like putting little areas inside each of these BSP cells. And then after that we connect them, and then that's basically it. So we'll see. I've never used this algorithm before, so it'll be interesting. Okay, so if I just hit play, we should hit that breakpoint or crash. That's also a thing that could happen, I suppose. Okay. All right, the split basically just went insane and kept splitting forever. It seems. Yeah. 187,000 nodes. Okay, so why? Max depth is 4. The depth is going down. Okay, and I have actually crashed it, so I do need to stop. This should be the escape case, so once the depth reaches the max, I guess we don't really need to do it like that. We could do this. Right, it's probably because I didn't initialize any of this stuff. Yeah, probably need to initialize that stuff. All right, let's try that. So once we get this working, yeah, the thing is going to be figuring out, we basically need to generate a box that sits inside of the bounds of the BSP. Okay. Binary space partition, yeah, that's the one. I was trying to remember what that was called again, what that stood for. But yeah, that's the one. We're trying to do BSP dungeons, basically. I've never implemented it before, so yeah, I've had my first infinite recursion crash so far, so we're off to a good start. And let's see if we get a second one. Why is that not going to hit? That breakpoint should hit. Okay. Oh, fucking hell. I think we got another one. Okay. What am I doing wrong here? So, did we get like a bajillion of these again? Yeah. 200,000 nodes. Not what I wanted at all. What I'm wondering is happening, maybe... Oh, wait, this code is screwed up again. Wait, that depth is not right. It needs to be this depth plus 1, which I think is what I had the first time. I only know BSP from Doom for occlusion culling. Not sure how BSP would be implemented for procedural generation. Yeah, it's I have seen some videos on how they do like the I think it was the old like what do you call those engines where they do the vertical line of pixels basically. I think I've seen it used a lot for that kind of stuff. But yeah, for procedural generation, we're basically following this kind of like implementation guide. And I'm basically just going to break up, so generate the BSP tree randomly. So we end up with this. I should zoom in so you guys can see better. End up with this, and then we put rooms inside each of those. So the black is the actual dungeon rooms, and it stays within the bounds. And then we basically just walk back up the tree, connecting the rooms together. So we end up with something like this, hopefully. if I can stop screwing this code up. But yeah, I think unless I'm doing an accidental copy maybe in one of these things, but I'm trying to not do that and just do references. Because it seems like the depth isn't propagating down for some reason. Yeah, we'll see. How's your project been coming along, Game Dev? I checked out some of your videos, by the way. Very cool. The BSP is just for the generation and isn't really persistent, but attempt data structure of the generator. Yeah, exactly. Yeah, I'm gonna eventually convert it to like cells, like a Sudoku grid type thing, and then just use that to generate the actual actors that get put in the scene. Veil 1.3 drops tomorrow. Very cool. Very exciting. I still haven't charged up my thing to try it out, but maybe I'll wait for the update. Hope it's all going good. We're trying to work on an update at the moment too, and it's been a pain in the ass. We had HLOD crashes today. We had foliage instance crashes. We use this plugin called Smooth Sync, which handles like network syncing of physics objects. Crashes there. A bunch of our quests stopped working like right as we were trying to ship this performance patch. But yeah, so hopefully you haven't been facing... Oh, here we go. Yeah, that looks like a reasonable number of things. So now we have the BSP, which has like a root node. Okay, so we're not setting... Okay, this is not actually working. Okay, this is not... It's close, but it's not actually doing what I want. Split. Been going well, working on a lot of boilerplate stuff, more interesting stuff to work on in the near future. Nice. Very cool. So pretty much only the depth was changing. Which is weird. I'm sure I'm just making a problem for myself by doing it like this, but... So the split function gets called. We should be updating these. Yeah, because this is a reference in this function that gets added to the array, I feel like this split should be fine with this. Like, I'm adding this to an array by reference, but then calling a function on it after, which edits member data, but I thought that would be okay. It seems like it's not. Because yeah, none of the other properties on this stuff is actually getting set except the depth. Which means these are staying as the default value. Yeah, so I'm adding to an array because there's the BSP node, which is the actual like you know, one of these basically, the room essentially. And then there is a struct that represents basically the whole kind of dungeon. And because I can't, as far as I know, reference the node within itself, so I can't do like that, I basically have an array and use the ID as an index, like as a kind of like a pointer. You reckon use an array of pointers? I could do that. So you reckon make these pointers, eh? And then put in the, like that. Yeah, maybe I am accidentally copying with that T array, huh? I thought because I was passing in the thing by reference here, when I added it to the array, it would pass in a reference, but maybe not. Maybe that's not how that works. And I don't really want to use objects for this. How do I keep losing my vape? What the hell? Yeah, it's behind my mic. The lifetime of the references I pass in, it basically lives within the lifetime of this function, I believe, because I'm putting them on the stack. The actual BSP should, as far as I know, get cleaned up at the end of this, unless I'm wrong about that. That won't work. So we basically create the root BSP, then we create a root node, then I add the node to the array. That reference dies at the end of the scope. That's okay though, because I would have already generated everything by then. This split function will recursively do it, and I have the data, I guess, for the rest of this function, which is all I need it for. Once I exit this generate function, we'll have actual actors spawned in the world rather than like the BSP structure anymore. Or you think that's still not a good idea? You need to store the node somewhere persistent and use that reference in the array. Right. Okay, well I can do that. If you only have 2 children every time, then I would either use indices into the array or unique pointers as children. So I am using indices as the ID. You can see right here, indices. But unless I can do pointers, can I do that? Like, because, oh, I can do pointers. Okay, in that case I wouldn't even need the array, so that's probably what I should be doing then. Yeah, okay, cool. That will make this a lot easier then. So let's see, I don't really need this anymore then. Let's change this out. So if you want to forget about memory management, I would recommend using 2 unique pointers as children. But when they get cleaned up at the end of the scope, as long as I don't like new one up, obviously. Okay, if we update this function, we create 2 new nodes, we update their depth, we don't need to add them there anymore. We just say child A equals I guess the reference of a new thing. Is that how you do it? How do I make this a pointer? Children will recursively be automatically freed when the parent is out of scope. Okay, I guess, yeah, sure, we can do that. So you want unique pointers? We can try that. Okay. All right. Well, yeah, that sounds like what I want. But how do I, let's see, T unique, can I construct one like this? Yes, okay. Otherwise, you use roll pointers with new and delete. Yeah, no, I don't really want to mess with that. Oh, I see what you're saying. Yeah, I think I understand now. So yeah, when I create the pointer, I would lose scope. Yeah. Okay. I would need to actually new it. Yeah. Okay, cool. Pretty sure I understand now. Okay, so child B. Yeah, you can see I'm not the most comfortable in C++, but I guess that's the whole point of this project, is to learn. You can set them to null pointer as well. Okay, cool. Might as well do that so we make sure we know what the memory is at the start. It's not just random shit. Okay, cool. And now we can do this, and then we just want to then recursively split like this, and then just pass through the max depth. Cool. Make unique to create unique pointer. Oh, so I don't do it like this? Make unique. Huh. Allocates a new object of type T with given arguments and returns. Oh, okay. Okay. All right, and then we just split down to that depth, and that should be good. Honestly, if you know unique pointer and shared pointer, that's most useful in 90% of cases in C++ where you need to store a heap object. Unique pointer and shared pointer. Make unique allocates an object. If you want a null pointer, just set it to null pointer. Unique pointer versus shared pointer. Yeah, I'm not sure what the difference would be there. I guess shared ownership. All right, let's see if this finally gets us to the first freaking step of this function. Which is not down here. We're still trying to get this first thing working. What do we do? Unique pointer is only allowed to have one instance pointing to a particular object, so it's good for tree-like data structures. You can't have two unique pointers pointing to the same object. Oh. Yeah, that makes sense. Unique. So what happens if you try to do that then? It just doesn't compile? Or like it... That's interesting. It owns the data, so when it goes out of scope, it calls delete. Ah, that's cool. Okay, so the node equals attempting to reference a deleted function. What the fuck does that mean? Child A. Node make unique. Yeah, I mean that looks fine to me. You need to use move semantics to set another unique pointer to a point to the same object. It basically nulls out the other pointer, so it owns. It's now pointing to nothing. There is no copy constructor or copy assignment, only move constructor and copy. I guess I should make this a T unique pointer as well then. This is like Unreal stuff, right? Or is this like is this C++ like just has all this? Wait, what the hell? Oh, there we go. Shared pointer uses runtime reference counting to track how many shared pointers are pointing the same data. I see. Yeah. Gotcha. Okay, so we do this, then we don't need to do that anymore. And then we just split. This is both Unreal and C++. The standard library has these as well, but Unreal has their own variations. Okay, gotcha. Yeah, that's cool. Adding it to my Gandiv list. All right. Okay, so this is talking about attempt to reference a deleted function. I don't really know what that is on about. I guess I can get rid of this now. Unique pointer is the lightweight wrapper around a pointer, and new and delete. Shared pointer is more like a garbage collector, yeah. So it has some overhead, but so long as you're not copying shared pointers all the time, it doesn't cost anything. Yeah, makes sense. Okay, I don't think that's the problem, but I'll try and compile again anyway. It's like talking about like copies and stuff here. I must have the syntax wrong. Compiler has generated operator equals here. Implicitly deleted because a data member invokes a deleted or inaccessible function. I guess I need an equals function. Maybe. Unique pointer is not copyable, so the whole structure is no longer copyable. Yeah. So it's equal, I guess, if, I don't know. Well, it's just never equal, honestly. That's probably bad. No, I don't want to be copying this structure. That's probably really bad, actually, to do that. Still trying to generate that function, though. What? There must be something I need to do to this array to get it to compile then. The reflection system expects them to be copy assignable. You should add type trait specialization immediately after your class to tell the reflection system that it is not copyable. Okay. Well, yeah, true. I guess I don't need usestruct. Just do a normal struct. Yeah, I guess I don't need reflection on this. That probably is the easiest way. Out of interest, though. Traits, what the fuck? Struct ops type trait. So you would do this. That's interesting. Never seen that before. You're getting into the weeds with the type trait system, yeah. So I just want to see, I will get rid of usestruct, but I just want to see, like, so that is going to basically tell the reflection system that you can't copy this, I guess. Oh, hang on. And I still have that, god damn it. But it seems like it's going to be happy with that. Yeah, interesting. Okay, well, actually I'm going to just leave that commented out because that's interesting to know. And I will definitely forget the syntax for that. Alright, anyway, let's see if we are now in business for the first frickin' step of this function, which I thought was going to be quick. You can do a lot of cool stuff with type traits like custom net serialized functions for structs to pack them before replication and custom equality operators. That's cool. I see a bug. Uh-oh. What'd I do? Split alpha, splits. You should assign the child node to a member, otherwise it will immediately be deleted. You should assign the child node to a member. I'm really trying to think about what you mean here. Oh, the root node? Oh, right. Really? So it'll get deleted straight away? I thought it lasts for the rest of the scope. Yeah, it is temporary. I do want it to be deleted right here, basically. I guess. Well, I mean, I don't have any reason to keep it beyond that. Maybe it would be handy to keep it for something, but... yeah, it'll last for the scope. Okay, yeah, I think that's intentional then, maybe just bad design. Alright, let's see what happens. Okay, so... oof. Okay, root node has a bunch of... so split alpha, depth 1, depth 2, depth 3, depth 4, and no children. And everything's getting randomized. Yeah, nice. If that's the case, you don't even need to heap allocate it. Right. Just for the root node, okay. Can do that. I don't even need that either then. Like that, okay. Construct it without make unique. Okay, well that works, so that's good. That's our first step done. We have the actual BSP ready to go. So now what I need to do is generate an area within these. Room with random size in each leaf of the tree. Okay. So I guess for that then, what we'll do is I mean, we could do this as we're generating, actually. We don't need to do it after we've split necessarily. We could do it right here. Wait, it's only the leaf nodes. So I guess when we hit a leaf node before we return, we will generate the data. Now rect, is that something that I actually want to use? What is this? No. F rectangle, F rect, rect 2D. I just need some sort of structure for having a rect. If actually I'm trying to remember, there is one, I'm trying to remember what it was called though. Okay, whatever, let's just make our own, I suppose. Okay, oh, that's what it is, isn't it? If bounds. No, okay, whatever. Okay, we have one of those, but in the room bound, so this is, I'm trying to think ahead of time how I'm going to do this, but because the X is going to need to be like, let's see, I need to extract like this size basically. By the way, unique pointer method is probably the easiest way to make this data structure, but the most efficient, if you don't care about adding children at runtime, is a flat data structure with an array and indices for children. Yeah, that's what I had at the start. But yeah, I was using T-array. I guess I should have just used a normal array. Okay, so how am I going to extract this? So let me do a simple case. Alright, so this is one side. this is the other side of that same split. And then we've got these ones. Okay, I think I have a plan. So, yeah, no, all good, all good. Yep, it's good to know that would be more efficient. Okay, so what I'll do is I'll call this like room bounds, or like node bounds. And I'm actually going to calculate it for every single one of them rather than just the last one, the leaf children. Because I think it's going to be useful to have. So what I need to do basically is I need to set the children basically as we do this. So child A dot room bounds dot x. So the x position, let's do this one step at a time on this. So if we have this, we split like here. I want to take child A is going to be the x position of the parent. And the xx is going to be minus the difference. Okay, so we need the width. Let's just do that here. Okay, so that's going to be the entire thing. So the width of the parents. Times this distance, which is the split alpha. Okay. And also this is just if it's horizontal, I guess. And then it's the same y as the parent, so same height. Okay, so that's child A, and now we need to do child B. That's basically the one on the other side, so that's this times 1 minus. By the way, if you're going to set each member manually and you're using C++20, you can use designated initializers, which is the best feature of C++20. 5.3. Yeah, I am on 5.3. Designated initializers. I don't know if I understand this. Oh, okay, I think I see. So it'll be like this: child A dot room bounds is like Am I getting this wrong? Yeah, all good typing on your phone. So wait, so okay, there it is. Usually define a strict type. I can do that. What do I call this thing? If node bounds. You mean in front of the brackets? Like I have now? Alright, so then we'll just, do it like this, I guess. Okay, so we got room X, we got this one is the XX, this one, and this one. Yeah. I usually enter after each member I initialize to make it more readable, yeah. It's kind of like more lines of code, but yeah, I guess it's clearer. Okay, so yeah, we do this, and then for the child B, the starting X is going to be like the right side of the one before, and then plus, and then the end of the parent, so like this. And then the same height. Okay, cool. You can even nest initializers for inner structs. Oh, okay, that's cool. Yeah, that is quite cool then. Okay, cool. So that is the right split. Now for the left split, that's the horizontal split. So it's like that. So now for the other one, I think it should be pretty simple, but that would be like this. So child A, child B, I should have labeled these. So the X's are going to be the same. And so for the A, the Y is going to be the same Y, and then we've got the width times the height times the thing. So this will be like that. And then the B is going to be starting at that lower level and goes to, yeah, the Y of the parent. Okay, pretty straightforward then, not too bad. Okay, so now we should have the actual bounds, but what I need to do is quickly make it so that the root node actually has some bounds. So this will be x is going to be 0, y 0, and then xx will be what is it called? Max size. Okay, so now we have an actual kind of world space representation of this as well. So let's compile that and see if that works. I should probably figure out a way to visualize this, but we should be able to see in Rider. Oh, they have to be in order though? Okay. Yeah, that's a weird rule, but sure. Okay. Not sure why it's like that. Yeah, I don't know. Because like if you're putting in the name, you'd think it would be able to figure it out, but... Yeah, okay, so this has got us basically somewhere between these steps. Like I now know the actual size of this, so I can generate this a lot easier. I am trying to decide at what point I switch to actual tiles. It might be after this step potentially. Okay, so let's see, root node. Okay. Wait, what? Null pointers for the children. I think I read somewhere that where they initialize them in member order and don't want ambiguity on what runs first, but for 99% of cases it doesn't matter. Yeah, that's interesting. Okay, why did we not set the children though? We return straight away, I guess. Oh, because I stopped on that line of code, that's why. God damn it. Okay, root node. Child A. Okay, and then it should start, yeah, from there and go to the end. And then the Y. Yup, that looks right. Wait, but then it stopped looking right immediately on the next step. So child A. That does not look right. Oh yeah, no, we're doing a vertical split, are we? Yeah, we're doing a vertical split. Okay. I don't know why this is true then, but yeah, okay, that makes sense. Children set within that function. Yeah, that was my bad. Okay, cool. So now we have that. What I think maybe I'll do is at what point do I convert over? Let's do the next step and then I'll convert it. So pretty much now what we want to do is when we get to the max depth, this is kind of wasteful to have this data sitting in a bunch of nodes that don't do anything though. But I'll just put it here and then I can refactor it out later. So room bounds is actually going to be the actual room within the cell. So now pretty much all we need is room bounds. I guess I didn't even need the names. I could have just done it like that, huh? Yeah, but that's fine. So the X. So now how do I generate a square within this square? So what I'll do is something like this. Actually, I had a thing, didn't I? So the width can be up to the width of the parent. And this can be up to this. And now we need the X position can be anywhere between our current X position and the end minus the width we just decided on. Alright. And then we just initialize with that. There is a way to use rand with the seed value. Yeah. I do need to do that. I haven't done it yet. I do it for all the village stuff. But yeah, I just use this because it's quick for now. But yeah, I do need to use the random stream for this. Okay, so then we got X position, X position plus room width, Y position, Y position plus room height. Okay, and that will give us the actual decided on like size of the room. Only for the leaf nodes. Okay, let's just also do this. Okay, and then we return and stop splitting from there. Okay, so now let's double check that. And then I think I'll convert to cells beyond this. So it'll be like convert to cells or tiles in this array that I have right here. Because right now we're just dealing with random float values. And then we need to do the connection, because the connections I want to be done in the tile. Like we need to have already converted before this point. So we might as well do it like between these two steps basically. Okay. This has been a little bit more complicated than I thought it was going to be honest, but we're getting through it. I'm also going to need to put like probably some checks on here to make sure the rooms are like at least a certain width, because otherwise, you know, then if you have less than a certain amount, you might not even generate a tile, which would be weird. Okay, so root node. Okay, so none of these are going to have actual room bounds until I get to a leaf node. So this is a leaf node because it has no children. How's it going, Takatao? Welcome in. Thanks for the subscription the other day, by the way. Okay, and then the room bounds. do not look correct at all. At all. Okay. So between that 0 and width, and then the position, so that's just the X pos, which is the room bounds minus the width of the side. Like so we're going negative on the X component right here, which maps to this. So to be negative, the lower bound would have to be negative. But we're passing in its own X value. Okay, let's just breakpoint one of these functions, I guess. It's going to be the quickest way to figure this out. Wait, what the hell? Why are we here? Why is it trying to breakpoint this line? I don't ever breakpoint there. Okay, so the width, I cannot see for some reason. What the heck? So between 0 and the width, which is Unreal Engine has an editor. Can you explain why you always write code instead of using the editor? Well, you know, the code has to go somewhere. There's no code editor in Unreal. There you can do Blueprint, and actually there might be a plugin for a code editor in Unreal. But yeah, because I'm doing C++, I need to write the code in the actual editor in IDE. Yeah, unfortunately this channel is going to be pretty code heavy. It's what I do for fun, the code stuff, so yeah. Okay, I'm not sure why my breakpoints are acting up here, so let's just stop and resume, and I'm going to make sure my live compile's up to date. It is. Okay, this is weird then. Okay. Yeah, what the hell? Why don't I get to see this value? Well, should be a value between these, essentially. And writing code. The editor is for animation and modeling, and writing code is for game logic. Am I right? I guess at a high level, kind of, yeah. It's not Unreal. So Unreal has modeling tools and animation tools built in. Usually, though, in a AAA scenario, you don't, or like in a big studio, you use other programs for that too. So you'll use like Maya or 3ds Max or Blender for modeling and animation. The Unreal editor is mainly for linking together gameplay logic, like level design, like project settings, stuff like that, maybe some blueprint, mostly just like authoring tasks. But yeah, technically you are right, you can do animation and modeling in Unreal, and in fact I did do some animation in the editor That is a relatively new thing though. Okay. Roombounds.y. Like, I see the error of my ways, I think. And it's my own fault. I used very similar names for these variables. And that is confusing me. There we go. That should be better now. Late night dev sessions are peaceful. I'm glad you think so. They are peaceful. Okay. Don't know what's going on down here. Let's just ignore that. Let's get down to a leaf node. Okay, room bounds. Here we go. This looks more reasonable. I just need to make sure basically this room bounds exists within the node bounds. So 7 to 30. Yep. That works. That looks good. And we'll check child B just in case. Yep. So the x and y and xx of these values should be between the two of these. So 6 is between 0 and 31, 12 is between 0 and 31, and yeah, we'll look good. Yeah, late night for sure. That's where I usually do have the most peaceful sort of programming experience. During the day it can be a little stressful and annoying if like people are interrupting and whatnot. Cool. So that's working now. So now I need to convert to tiles. Trying to think of the best way to do that. So if I set the number of these and then for loop through max size, what I'll do is I'll say like if, so let's see, so if what do we got, root node dot is position filled, and then we'll do x times whatever. Then we want to set something here, so layout data x times max size needs to be like 1, I guess, because that should be 0 filled. I might also start with a Y on this, just so I can do some easier printing. Okay, let's just do like this. And then I want to do a print or something for the row, so I'll do row string plus equals. If it's filled, I'll do an X. Otherwise, I'll do a space. And then right at the end, we'll print it. This can be in display. Sorry, row string like this. Did I get all the parameters in there right? Hang on, log temp error. I'm missing a parameter, aren't I? Formatting string must be a const. Late night is not peaceful on Black Ops, no. What am I doing wrong with this log? Have I forgotten the syntax? Do you need that? I didn't know you actually had to have that. I thought that was optional. Okay. Ugly. Ugly, ugly. Okay. Latest Call of Duty. Okay, so now we need this is position filled. And this is going to get called on the root. So return child A is position filled. So we're going to do more recursion. X or that is supposed to be Y. Or child B is position filled. But we do need to handle the case of if this is a leaf, because otherwise it's just infinite recursion. If it's a leaf, then we can actually return the proper value. So yeah, macro print, that is a good idea. That does both. Yeah, I did log this time because I'm printing the actual like dungeon as text, so I kind of want to see it like in text format that I can copy paste. But yeah, usually I do screen messages, but having a macro that does both would probably be helpful. Okay, so we just want to return if x is greater than or equal to room bounds dot x, and x is less than or equal to room bounds. I don't know if I need the equals. So that's the width, the left and right, and now we need to do the other one. So y is greater than room bounds dot y, and y is less than room bounds dot y. Okay, and that will be our exit case. Yeah, the G-engine syntax is quite annoying. All of the print stuff is kind of annoying, honestly. Like, just, I guess this is what you do, eh? Being able to just do that. That would be a lot easier. Okay. Right, so this is going to be recursive. Hopefully, again, recursion's a little iffy because you can really shoot yourself in the foot if you don't get the exit case right. But hopefully I got it there. Should be good. Okay, yeah, so now we can go through and track which ones are filled and which ones aren't based on the route. Did you just give me the whole thing? Hell yeah, dude. Thank you. Where do I put it? Anywhere? So now it's like this, I guess. Oh wait, you still put some args in a printf, but that's how you do it. Okay. Yeah, cool. Nice. I will investigate that because that will be helpful. Do you just dump that in kind of any header file, I suppose, like one of the root header files, like I guess the project main header file, the module or something. Very cool. Yeah, I've never made a macro before in C++, so that'd be cool. All right, so this should go through and actually print our dungeon and at the same time generate the layout data. Or crash, one of the two options. Or just not work, I suppose. Alright, I'm going to sort this out and then I'm probably going to head off as well. Because it's getting a bit late for me and I've got a big day tomorrow. Alright. Let's see, so output log. Play. Pray we don't crash. And then output log. It definitely doesn't look very dungeony to me. Oh, that's the correct one? Can try that. So yeah, I guess I'd just put it in like my module main file or something. Or I guess its own file. Because now I have to probably include that everywhere, but if it was like so how do you use it though? So you still do this. Wait, no, there's a time there, isn't there? And then I swear there's a time you've got to put as well. Pretty sure like right here. Oh god, I don't know how to edit this though, but like it would be like that maybe? I should just not fuck with it, shouldn't I? And just make sure it actually works first. Oh, like you don't actually have to put in any of this? Right. So, wait, %I. Okay. Yeah, I think it's mad because like I need to update it to take in all these arguments. At least the time to display one, probably. How about that? Inline the macro and see what it's complaining about. How do we do that? Right click on the macro and show context options, then inline. Show context option. Substitute macro call. You maybe mean at the root? Maybe I'm not supposed to do that, but I'm pretty sure this function does take in like a number. So that's how it works. It just paste shit in like that. And now there's like too many brackets and stuff. Okay. I think I can figure this out. So that number at the end, what is that? Display color, string. VA args. Looks like maybe one too many brackets. Yeah, I think that was it. Macros just glorified text replacement. Yeah. Cool. That is super helpful, thanks. And that's actually good now that I know how to do macros as well. Yeah, anyway, yeah, this dungeon does look kind of fucked. Not really what I expected to see, if I'm honest. So let's do a dot for the empty cells, maybe. Generate. Okay. Right. I think we might be going down too many layers. F-string format, yeah, I do usually prefer that, but yeah, that works. Because I forget what the characters mean in here. I know S is string. I think D is float or something, or double. Okay, so yeah, I think we're just going down too many layers maybe. So let's split up to 2 levels deep to start off with. I should definitely just make this a property that I can edit, but no, that doesn't look right. It's supposed to be separate. Cells. It looks close. Automatically deduce syntax. Yeah, that would be cool. Right, they are. They're overlapping. That's what's going on here. Yeah. The node bounds. That looks right. And then 2, 4. I might just have a screw up in my logic. Yeah, because both of these calculations look right, but then wait, but then how is it possible they overlap? That one ends there. That one ends at x2 7, and this one starts at x1 8. See you later, Tucktail. Thanks for tuning in. All right. I actually think I'm gonna leave the stream there anyway. I do have a big day tomorrow. So yeah, tomorrow or the next time I stream, I will look at why we have a problem, it seems, here with some of this math. Node bounds. Yeah, because if the rooms overlap, like see in this picture how the rooms are supposed to not overlap. Yeah, some of ours are right now, which is screwing everything up. So yeah. Anyway, I'm going to leave the stream there. Thanks for your help as always, Gandev, and thanks to everyone for tuning in. And I'll catch you all in the next